Okay, so for chapter 3, slide number 3 we completed already. Only few slides that I skip, I may return to it if I want it. So we have to start today on chapter 4, slide number 4. Okay, most of the past slides we use the move syntax most of the time. Move here, move there, move there. Now we have to start with the arithmetic syntax. Arithmetic syntax, so we have to start on chapter 4. Looks quite easy because you have to learn back the operation of add, subtract, division and multiplication again. You are using add, subtract, multiplications and division again. So this is back to the primary school area, but now you have to use it for the microprocessor class. So it's not that easy. So we have to start with add. Add function or add syntax. Okay, the add operation. Add operation is going to be like this format. Add dot size. Size is either byte, words or long word. And then you have the source. SEA means source effective address, comma, data register, or vice versa, data register to destination effective address. So you have the source at the front, you have the destinations at the back. So we have the source and destination. So you have to really, you have to really familiarize yourself. Where is the source? Where is destination? It's very simple. The last one will be the destination. Very simple. Okay. So this is the machine code format. This is considered from the data sheet. So data sheet, I already uploaded few more data sheets, right, in the ULEARN. So please grab those data sheets and also grab the tutorial. The tutorial is very important for you if you want to see the formats of some of the questions. So try it. Alright, so we are going to start with add first. This is a table from the data sheet again, it's the same thing. Now look over here, the command. So let's start to write. The value for 1000 changed to 2000. Look carefully. Because in simulator I cannot use 1000 to save any data. And my code is starting from 1000. So change this one in your slides. If I'm not mistaken, it starts from 1000. So change to 2000. So this exercise is coming from this syntax. So go and write those things. Quick, in 5 minutes only. Look at your slides and write down this code. Why there's not that? The color should be different. From the slides. Slides is given directly the values, whereas in simulator we have to put one by one. Actually, because if I use the data, I that's why I reserve some. I cannot simply define myself with the 1,000. I cannot original 1,000 and 5,000. I cannot use it. Now it's 2,000. Yeah, so you change origin 1,000, then you define constant, you have ADDI. So that's why I put somewhere else. Alright, quick one. Means that after how many classes you should know very easy how to write the codes. So look at the slides. Compare the slides results. So the semicolon is a commenting out. This one is commenting out. So you have to use it one by one. Comment out means that I ignore the lines. So each of the lines should be independently executed. So let's try the first one. Done? Everything done, right? I don't see people typing it anymore. So add dot by D1, D2 means that you are going to add byte size at D1 and D2. Finally, the answer will be saved in D2. So you run your execution one by one here. Here is the one, right? So I run it. Because it's already a normal codes that I have used so far. is add dot by D1 to D2. Look at the second one first. Hold on. Add dot W hash dollar sign 3400, which is a number, to D1, means that you are going to add word size, this 4 plus D1, 4 digits only, and the answer will be saved at D1 register. The third one, add dot long D1, the whole register's value for D1 going to be add up dollar sign 2000. That is the locations of the memory. You have to refer to 2000, get the long word, add up, and then finally you have to save it back to the original 2000s area, because this is the destination. Okay, let's look one by one from the codes. Here is the first one, D1, D2. Alright? So step by step, first one, put the first one for D1 already given there. The second one move to D2. Now add dot by D1, D2. The register that you're expecting to be changed is D1. D1 must be changed because you're going to add up this number. D1, D2. 7 plus 4. You have to use your calculator in hexa. 11 is equivalent to B. So the answer is BB. The final answer must be 1122 5544 BB. Agree? Alright, next one. I have to close this one, open up the second one, and comment out the first one, execute again. So the second command from the slide is add.w, add.words. This is a number, hash is a number. Dollar sign means in hex number. Comma D1. D1 is given this number, so 5544 plus 3400. What's the answer? In calculator. Compare in calculator. So 3400 plus D1 is equivalent to this number. Using only words, only the last 4 is 5544 plus 3400. The answer will be saved in D1. So I am expecting the value over here will be changed. So let's run it one by one. D1 is given over there. D2 is given over there. And the command will add those 4 numbers at the back and update it back to the D1 area. Same answer with calculator, right? Yeah. So the answer is 8944. So go for the last one. So close this one and open up the last one and execute again. Now the last command is add.long D1 to the location. Values is from the location. So you have to look at your memory location at 2000. View your memory. View your memory. At 2000. Just now your code, I already put in origin 2000, right? After that origin, I define constant.long. That is the value AA, BB, CC, DD. There's the contents in the memory already. So you are going to add up D1 plus still a long number from the area of 2000. So the value will be AA, BB, CC, DD. That's the value from 2000. You have to add up with D1. Add first from your calculator. And then you run the syntax. The value will be updated back to the 2000 location. So let's run it. Here. Alright. Now my memory over here at 2000 still remain the same one before I change it. So let's run the last one. Look over here, look at the 2000. I run the last command. The answer is saved to the location DB, DE, 2221. Okay? Add is very simple. Okay, tak ada masalah. Should be okay. Now move on. After add, we have another one which is add address. Add is add. Add A is for the add address. The command here for any A at the back after add is confirm that the destination must be an address register. Must be, The thing over here that I remove out, that the slide says there's a sign extend rules. You have to remove out because when I read the book, there's no sign extend rules. Too late. So there's no sign extend rules. In the slide they put sign extend, but there is no, because I double checked with the book, there is no sign extend rules expected for this add operation.
sorry.
Now, 5 minutes only. Come on. For ADDA, we are going to look at the questions on the slides.
This is The slides giving you all this information, and most of the tests or final exam will giving you directly like this. So you have no simulator to run on. So now look carefully. Given A1 is address register number 1 is this number, A2 is given this number, A3 is given this number, D4 is given this number. This one is the locations of the memory for 8000, and the contents for it is over here. It's better to put $sign over here. It's the same thing. If decimal, it's also the same thing, doesn't matter, but I prefer to put $sign 77882233, which is resembles hexadecimal. Okay, now at address.w D4A1. You have to add word size from D4 and A1, and the final answer must be put at A1. Okay, D4 is given this number. The last 4 is 1100. A1 is given this number. So you have to add word size, means that you have to take this number 8899 plus 1100, and you have to update back to A1. So the contents for A1 all must be back to 6677. The last 4 is updated. The value will be 99 plus 1 plus 8 is 9 and 999. So write your code. Correct? So this is to add A, execute. So look at the value for A1. This is put in A1, A2, A3, all put over there already. So D4 is the last one. All the numbers there. So now D4 plus A1 for word size. Look at A1. A1 will be updated over here. So run it. You have the answer. Okay, now open up the second one. Add address.long hash $77 to A3. Open up that one.